The photo shown was taken from a page of the Soviet Encyclopedic Dictionary, the 1951 edition. Spaceflight had not begun. This was all observed through telescopes. All data is taken from open sources. According to the official version of the structure of the universe, Mars is the fourth large planet from the Sun. It appears in the sky as a bright reddish star. The average distance of Mars from the Sun is 228 million kilometers. Its orbital period around the Sun is 687 days, and its diameter is 6,780 kilometers. A day on Mars lasts 24 hours and 37 minutes. Mars is surrounded by an atmosphere that is much less dense than Earth's and is very poor in water vapor. Most of the surface of Mars has an orange color and apparently consists of arid deserts. A smaller part has a darker greenish tint. At the poles of Mars, white polar caps can be seen. The temperature on the sunlit surface of Mars ranges from -80 to +25 degrees Celsius. The axis of rotation of Mars is tilted to the plane of its orbit at an angle, almost like Earth's. As a result, Mars experiences a change of seasons. The arrival of summer in one of Mars's hemispheres is accompanied by a reduction in the corresponding polar cap, which appears to be made of snow, frost, or ice, and by the darkening of greenish areas, indicating the possibility of vegetation on Mars. And we read all this in a dictionary from the year 1951. On the surface of Mars, numerous linear formations are noticeable. The so-called canals, which are believed to have a natural origin, cracks, fault lines in the crust, and similar features. Two small satellites, Phobos and Deimos, with diameters of about 15 and 8 kilometers respectively, orbit around Mars. Here we see the channel of a Martian river. If you look closely, it really does resemble a river. The tributaries are clearly distinguishable. If there is life, then Martian plants and animals are not very spoiled by nature. So what is the climate like on Mars? It became possible to answer this question more precisely only after Soviet Mars stations and American Mariner-type stations flew to the planet. The descent module of our Mars Tri-Automatic Space Station became the first messenger from Earth to descend to the surface of the distant planet. The American stations managed to photograph a large part of the planet's surface. The photographs revealed dry riverbeds, ravines, valleys, and volcanoes. If there are volcanoes, it means there are areas with more heat and moisture. Mars turned out to be even less like the Moon than was assumed 10 years ago. That is, in 1963. In the picture, there is a section of the surface of Mars. Gullies flowing into a canyon are clearly visible. At the bottom, a vertical section along the dotted line is shown. In 1969, scientists from Texas University and the California Institute of Technology determined that the total amount of water on the planet is 1.6 cubic kilometers or 4 million tons. The latest data received from artificial satellites of Mars indicate that the planet is losing water, which is escaping into outer space. Here we see clouds over Mars, but the main thing is that there is water on Mars. The atmospheric pressure on Mars is about 10 millibars. That's like being at an altitude of 30 kilometers here on Earth. It's about 1/100th of one atmosphere. Here we see the southern polar cap of Mars. At the top is a photo of the entire cap marked with a black arrow. Here, the area indicated is enlarged in the images below, which were taken respectively on the 19th, 29th, and 1st of December 1971. A stream of melting snow is clearly visible, which in its appearance resembles a river delta on Earth. The first serious study was conducted by the Soviet astronomer G. Artikov. By applying special methods of photographing through a telescope, he came to the conclusion that the changes in the coloration of the planet's surface are probably related to a special form of plant life. This is how the foundations of the new science of astrobotany were laid. What do we see today? The average atmospheric pressure at the surface is about 0.6 thousandths of a kPa, or 6 millibars, which is about 100 times less than Earth's or equal to Earth's, at an altitude of almost 35 kilometers above the surface of the Earth. So let's draw some conclusions. From 1953 to 2018, all visible vegetation disappeared from the planet Mars. From 1973 to 2018, the atmospheric pressure on the red planet decreased from 10 millibars to 0.6 millibars. That's as much as 16 times. Many more examples can be given of differences in data about cosmic objects that were observed by astronomers. But the fact that the planet Mars took its last breath no longer seems like a fantasy. The black satellite of Mars. A detailed study of a photograph of one of Mars's satellites, Phobos, showed that the satellite has an egg-shaped form with dimensions of 18 by 22 kilometers. Previously, Phobos' diameter was estimated to be 16 kilometers. The reflectivity of the surface of this Martian satellite was calculated, that is, the value characterizing the ability of a celestial body to reflect the light falling on it. In astronomy, this is called albedo. The albedo of Phobos is only 0.65. In other words, the surface of the satellite reflects only 6.5% of the incoming light. This is remarkably low, lower than any other body in the solar system. Until now, the darkest bodies were considered to be Mars, with an albedo of 0.154, the Moon with 0.115, and Mercury with 0.1. This means that future space travelers, as they approach Phobos in a spacecraft, will see it as very dark, almost black. Mars has two natural satellites, Phobos and Deimos. In ancient Greek, their names mean fear and terror. They are relatively small. Phobos is up to 27 kilometers across, and Deimos is 15. They have an irregular shape. The first claim that satellites of Venus had been discovered dates back to the 17th century. In just 120 years, up to 1,770, more than 30 observations of satellites were recorded. At least 12 astronomers, that is, 12 astronomers put their authority on the line to prove the existence of celestial bodies near Venus. But by 1770, the search for Venus's satellites had practically ceased. Mainly because it was impossible to repeat the results of previous observations, and also because no signs of a satellite were found during the observation of Venus's transit across the Sun's disk in 1761 and 1769. So it turns out that satellites can be adjusted, removed from planets. Astronomers record such phenomena that are signs of intelligent activity by more advanced civilizations, but they don't go beyond subtle hints at such versions. You can figure out the satellites of other planets on your own. There are many of them, for every taste and color, but some are similar to the Moon, and some have a magnetic field and atmosphere, just like Earth. Not only do the planets in the solar system move in a flat circle, but even small cosmic bodies are also subject to this influence. The rings of planets are systems of flat concentric formations made of dust and ice, rotating around the planet in the equatorial plane. Rings have been discovered around all the gas giants of the solar system: Saturn, Jupiter, Uranus, Neptune, as well as the asteroid Chariklo and the dwarf planet Haumea. The rings of planets are always located exactly in the plane of the equator. The asteroid belt is a region of the solar system located between the orbits of Mars and Jupiter. It is a place where a large number of objects of various sizes, mostly of irregular shape, are concentrated. These objects are called asteroids or minor planets. In the 18th century, astronomers Titius-Bode discovered that the distances of the known planets from the Sun followed a law of geometric progression. This pattern was called the Titius-Bode rule. However, in this sequence there was one unoccupied spot. There was no planet where one should have been between Mars and Jupiter. The reasons why the planet Phaeton was destroyed have not been determined by science. If such a catastrophe really happened, it must have resulted in a massive ejection of material into space. And that's exactly how the entire surface of Earth and Mars could have been covered with a uniform layer of clay and other substances, if Earth was flooded by flows of clay in the 19th century. But it didn't turn red for a simple reason: life wasn't destroyed on it, which can't be said about Mars. Of course, the time of Phaeton's destruction is just a theory, but it's still worth keeping in mind. Not long ago, we considered the date of the flood to be 11,500 years ago, but look at us now. Many people still live in houses that were built before the flood. So we can conclude that the destruction of Mars began at the same time when a series of catastrophes occurred on Earth and on the other inhabited planets of the solar system. This was from the 18th to the beginning of the 19th century. Earth managed to survive, but Mars did not. In fact, even in the 20th century, astronomers continued to witness the Martian civilization's demise.